Hello guys, I am Naga Prasad and welcome to the channel You Are a Physicist. Introducing Albert to you all here.
Hello, guys.
Albert is an imaginary listener of our session. He will listen with us throughout the session and Albert will ask doubts in between the session if he had one. Okay, Albert will return in between the session with his doubts. Until then, say bye bye to Albert. Okay, this is the series of NCERT Physics Class 12. In this series, we are going to cover the chapters and topics in NCERT Physics Class 12 book. Now we are going to see the chapter 1 electric charges and fields. Today we are going to cover the section 1.1 introduction session. Let's get into the section without any delay. All of us have experienced this type of shock or a feeling of crank while we remove a t-shirt or a sweater, especially during the dry weather. Have you ever tried to find the explanation of this phenomenon? Yes, this is because of the discharge of electricity within our body. The lightning we see in the sky during the thunderstorm is also an example of discharge of electricity. We also experience a feeling of shock while we touch the door doorknob of the car after sliding from our seat. Okay, while we traveling in the bus after sliding from our seat, and then we'll go to the to touch the iron bar. After touching the iron bar, we get a feeling of shock after touching the iron bar. So what is all what these are? How these all electricity created? Yes, this is because of the electrical discharge, and that discharge is caused due to the rubbing of your body with the insulating surfaces like the car seat or the seat in the bus. So we can commonly call it as a static electricity. Okay, this is the statement of static electricity. Static means anything that does not move or change with the time. Electrostatics deals with the study of forces, fields, and potential energy arising from static charges. Okay, in this statement, we can come to an conclusion that static is a thing that does not move, and electrostatics deals with the forces, fields, and potentials which are arising from these static charges. These static charges can't move from one place to another place. So, this is the statement here. Okay, Albert is here with some doubts. Let us hear what he's asking.
Can you tell me how static electricity has been created?
Okay, Albert, I understood your question. To know that, we have to first clear we have to clear with the Bohr atomic model. Okay, in this Bohr atomic model, we have negatively charged electrons, positively charged protons, and neutral neutrons which have no charge. Okay, this is the atomic model of conductor, insulators, and semiconductors. The outermost shell, which is in the blue color, is called as a valence shell. This valence shell, as it is an outermost shell, it tends to lose or gain electrons. If the outermost shell is have less number of electrons, like 1 to 3 number of valence electrons, the electrons in the outermost shell is called valence electrons. If the number of valence electrons is 1 to 3, then the atom should be a conductor, so it will accept electron from anywhere. And then for insulators, it will not accept any electrons, it will not conduct electricity, so the valence shell is full. Because of the valence shell is full, it will not accept no more electrons from this. It can lose electrons. The semiconductors, semiconductors can lose electrons and also can accept electrons because it have partially filled with electrons with so for example, the semiconductors have four valence electrons in this valence in the atom's valence shell. Okay, now just keep in mind all the structure of valence shells in of conductors, insulators and semiconductors. It will be helpful to understand how the static electricity is created. Okay, let's again take the Bohr's atom model. If we add one extra electron to the valence shell, the number of electrons will be high than the number of protons. If the number of electrons is greater than the number of protons, the atom is said to be in negatively charged state. Okay, if you remove two electrons from the valence shell, the number of protons will be higher than the number of electrons. If the number of protons is greater than the number of electrons, then this atom is said to be in positively charged. If the atom has equal number of protons and equal number of electrons, it is said to be in a equilibrium state. This equilibrium state is also known as a lower energy state. Okay, by this is a rule. Every atom by nature, every atom wants to be in the lower energy state, which is number of protons is equal to number of electrons. Okay, we are having an example scenario here. Okay, in this example scenario, we are having a man walking on a silicon carpet and there is a doorknob. Here we have to consider three elements. One element is the man walking. The man walking is a neutral charge, which is the number of protons is equal to number of electrons. The man is in the equilibrium state, and also the carpet is also in a neutral state, and also the doorknob is also in a neutral state. Okay, now see what's happening while he walks. While the man is walking, he will rub his legs in the carpet. Human body is a great conductor of electricity because the outermost shells, the valence shell, have some empty places to hold to accept the electrons from everywhere. So human body is a conductor, and also the silicon carpet is an insulator by nature because it have the full valence shell. So the valence shell is full in this carpet. So while the human leg is rubbing on the carpet tends to lose one electron from it. So it will become positively charged because it lost an electron, and the lost electron is accepted by the body of the human. So an extra electron is added to the human body. So the human body becomes negatively charged. Okay. Now, the carpet is positively charged, the human body is negatively charged, and the doorknob is in a neutral state. So, what if the human touch this doorknob? Now, the human body is in negatively charged and the doorknob is in a neutral state. Comparing to human body, the the doorknob is made of a metal. Metals have more valence shells to accept electrons. So the electron is attracted, an extra electron from human body is attracted to the doorknob. So as the negatively charged human body lost the extra electron, it again become to a neutral state, and the electron is traveled to the doorknob. This travel causes an electric shock to our body. This is the travel of electron from our body to the doorknob causes an electric shock, and then the doorknob becomes negatively charged as it has one extra electron. Okay, now the human body is had the neutral charge by touching the doorknob. Then what will happen to the carpet and to the doorknob? They are in positive charge and negative charge respectively. So the carpet should gain one electron to be neutral. So it will gain one electron from the atmospheric air and then it will become neutral. After that, the doorknob loses one electron to the ground and then it will become neutral. Now everything become neutral by nature. So the static electricity is nothing more than the travel of electron between charged particles. the travel due to the travel of electrons from our body, this is called an electric discharge. Due to the discharge, we are experiencing a feel of shock in our hand or a body part where we touching the conductors. So this is all about how electricity is created within our body, how electric discharge is created within our body. So we are going to discuss more about this electrical charges and fields in further more videos in the later videos. Until then, bye bye.